Hello, in this video I'll be giving you a crash course on white strip foundation design, what to do and what not to do when performing a white strip foundation design. I'll be working with you throughout from the beginning to the end of this white strip foundation design for a one-story building, beginning from the modeling and up to the design stage for just the white strip foundation, when to choose a white strip foundation and when not to choose a white strip foundation, either by based on the story height or based on the bearing capacity or by the height of the building. And also, good news, we are giving out 50% discount on our Ekidel mentorship training beginning from the 21st of this month, that's going to run through the 25th of this month. So if you want to be among the next batch for our Ekidel mentorship training program, you can enroll for that following the link below this video description. So see you on the main video. Let's go right now. Hello, welcome to Ekidel. We are trained future civil and structural engineer. My name is Justice Umwaka and I am your instructor. Today, I'll be showing you how to design a white strip foundation using the software Protastructure. You can use any of the version to perform this particular foundation design, but for me, I'm using 2025 to perform this particular white strip foundation for this structure, which is actually a one-story building. So currently right now, if you want to perform a white strip foundation design, you must know the reason why you choose or to use a white strip foundation, knowing that we have several type of foundations beginning from pad up to pie foundation, white strip foundation, mat foundation, beam raft, and so on and so forth. But there should be a reason why you are meant to choose any type of foundation design for that structure, and the reason should be based on one, the nature of the structure, two, the bearing capacity of that particular structure, or where the structure is to be sited. So the soil is a major factor, and also the type of structure is also a major factor. When I mean the type of structure, I mean the height of the structure, because if the building is very high, for example high-rise building, that will also determine the type of foundation you are going to choose. So in this case, this is just a one-story building, so we're using a white strip foundation. The major factor is based on the bearing capacity of the soil. From the soil report, the soil bearing capacity is a bit lower than the standard of the choice to use as a pad foundation. Knowing that a pad foundation, you can have a choice to use a pad foundation when the bearing capacity ranges from 75 kilonewton per meter square and above. So, but in this case, the bearing capacity is lower than 75. So that gave us the next option to move into a white strip foundation. But before then, there is a good news. If you want to enroll for Ekidel mentorship training, we are currently running 50% discount on our Ekidel website, which runs beginning from the 21st of this month through 25th of this month of October. So if you want to enroll for that, you can quickly go to our online or go to Google and type Ekidel mentorship program. Let me take you just there right now. So on your Google right now, just type Ekidel mentorship program. You will just see that will appear, Ekidel mentorship program. Now when you open that, on the first link that will appear, which you can see here on this, just click on it, and then when it opens, you can then choose your country currency, because our website powers different currency in Africa and other countries. So you can then come, you can see this is for Naira, you can see the price. We are giving 50% discount. So for those that have been finding a way to enroll for our mentorship based on the price, I think this is the time you can be able to enroll for that. You can then also navigate to other currency depending on the country you are. So for example, this is for dollars. For people that are using USD, this is your this is where this is the price currently. 150. Then for Ghana cedis, you can see that. So you just navigate to all other currencies, also Kenya shillings, that also goes, and also South African rand, that also goes for that. So the same thing, and other currencies too, Tanzania shillings, the same process. So that is it for that. And you can also go and then click on the more details, and then you will see all the training syllabus and what you are going to learn. Note, our mentorship training is a one-on-one training. It is not a group training. And then also it comes with software packages like Protastructure and Stonebridge templates and other software packages which will aid you on the training. We use Google Meeting for our training, and then it's a one-on-one, or a total of 20 projects, and this is the training syllabus, what you're going to go learn during the days. And then also it runs for 6 weeks duration, and then we train 3 days per week, and the remaining 3 days is for you to do your assignment. Now just read about everything here, and if you're okay with it and you want to enroll for that, you can then go on and then enroll for Ekidel mentorship. These are the packages that comes with the training, and then you can then go ahead and then enroll for that. Okay, that is fine. Now let us now go back to what we have for today, which is the foundation design for Y strip. Now back to our Y strip foundation. The first thing to do when you are designing for a Y strip foundation is, first you have to perform your foundation settings. Very, very important, because it is very, very easy to forget imputing the soil bearing capacity when you are performing a Y strip foundation. And once you forget to impute your bearing capacity when you're performing a Y strip foundation, then you are going to get a wrong result. So I always advise the first thing to do is to hit your setting center, which you can see here, and then move on to the foundation tab here. On the foundation tab here, you will be able to see where you'll be able to impute your bearing capacity. As you can see, in this case, this here it says allowable soil stress. So you come here and impute your actual bearing capacity of your soil. In there says soil unit weight, so I'll put here 18. Okay, then here now you have to impute your bearing capacity of your soil here. And note that when you are using a Y strip foundation, Y strip foundation begins from a bearing capacity below 75 kilonewton per meter square. Once your bearing capacity is above 75, then the first thing that should come to your mind is to try a pad foundation, a pad footing, except the number of stories is above 5-story building. When it's more than 5-story building, a pad footing can no longer work again. It will be very difficult because you'll be having a wider pad footing and also a bigger depth. And from the principle, the more you go in height, the more you need a deeper foundation to transfer the load of the structure to a suitable soil strata. But in this case, this is just a 1-story building, and the bearing capacity of this soil based on the geotechnical report is 65. So in the course of that, because it is below 75, which is the minimum bearing capacity, you have to use a pad foundation. So since it's below 75, but it is not below 60, we will have to try to use a Y strip foundation. It is when it fails, we'll then move to a beam raft or a mat foundation. So in this case, we are to try a Y strip foundation. Okay, so once you have set this now, every other things here can still be the way they are. Then come here and then say okay. But note, if you're performing other type of foundation, we will have to perform some settings here. But in this case, for a Y strip foundation, just impute your bearing capacity and you're good to go. And then come here and then click on what okay. So once you have said okay, now the next thing to do is to confirm the reinforcement that is used for the foundation. So let us go to our edit material now. Now these are the settings you are meant to do, all right, before hitting up to design for your foundation. Now we then come here right now and then click on edit material. Now then hit onto foundations. On this place now, come here and see the reinforcement that you chose for foundation. In this case, I will come here that says edit material, edit, and then I'll go to footing to make sure I have 12. Yeah, we have 12 here. Can you see that we have 12? So I'll come now and then say okay, and then say okay again. Come to links again and make sure also that I also have 12 around the links. Come here again and click on this place. Let's say again it's also there, 12. Yeah, that's fine, because I'll be using 12 for the footing and then diameter 16 for the beams. So I'll come and then do what, okay again, and then okay again, and then final okay. So now that I'm sure that I have 12 diameter of reinforcement for which I'll be using for the wide strip footing, while the 16 is for the beam, ground beam. So with this now, I'll then come out here and then see what, say close. So once you've done that, now we then hit onto the plan view, the plan view of the story 1. Meanwhile, note that before you must perform your foundation design, you must have already performed your structural analysis and design of that structure. That is to carry to carry the to get the total load on the foundation, which is the base reaction. So in this case, you can see that we have already performed our what design analysis already for the slab and for the beam, and make sure that everything is okay. And we have also checked for our interactive design. Then let's now hit on back now to the foundation level, which is the story 0. So I'll now click on what, on the plan view now, and make sure that my interface is showing story 0. This is the reinforcement for the slab which we did. I'll then come back now and then go to what, story 0. Double click on and make sure you are on story. Now once you're on story 0, what is a wide strip foundation, and what constitutes a wide strip foundation? Wide strip foundation consists of a footing and then a ground beam. Two of them comes together, and that is why it is called a wide strip foundation. So knowing that we have a beam and a footing, we are going to model our beam here as if we are modeling for a beam raft. But just that there is difference between beam raft and a wide strip foundation. The reason for beam raft is that beam raft has a bigger depth or a deeper depth of beam, while wide strip foundation has a smaller depth of beam. Not that small, but smaller. Now, for a wide strip foundation, knowing that we are going to insert beam first, I will then go and then click on what, modeling here. Note I'm on story 0. You must be on story 0. Then come and click on what, beams or beam tab here under modeling. Click on what, foundation beams. Now once you have done this, now the next thing to do is to set your beam parameters. In this case, I can choose to use 225 or 250. For me, I will advise, when you're dealing with a ground beam, try to use 250. The reason is because it's a ground beam, that is one, and two, knowing that your columns are 225 and the columns are going to sit directly on the beam, it is recommended and advised, or it is advised, that your beam, your ground beam, which the column is to sit on, should be at least bigger. Although if you don't want to follow that, you can still use what, 225. It is still okay, everything is okay. But for me, I want to use 250. Okay, that is fine. So then once you've justified your width of your beam, you then move on to the depth of your beam. Now knowing that this is a foundation beam and this is a wide strip foundation beam depth ranges from 600 minimum at least to 900, not up to 1000. Once it enters 1000, it is advisable you move to a beam raft foundation. So it ranges from 600 to 950. Now, knowing this range, you are meant to pick you are meant to try your design based on this depth, based on this range of depths, 600 to what, 900, 950, sorry. So but for me, I like to use 750 as my range for my ground beam. So I'll come here and put 750. Note, this 750 is not a standard. Remember, I gave you guys the range 600 to 950. So in this, which is what, millimeter, not in feet, millimeter. So in this case now, I want to use 750, which is within the range of 600 to 950 millimeter beam depth. So once you have put this now, the next thing to do right now is now begin to do what? Model your beams. Now note that when you're modeling a foundation beam, don't hinge it. You don't apply free moment or hinge. Don't apply that on foundation. You can only do that on the superstructure to release moments at the end of beams. But for foundation, don't do it. So in this case, now I'll then come and do what? Begin to model for my foundation. Alright. I'll then come and click here. Okay. I like to enter and then continue again from here to here. Okay, that is fine. Okay, then I'll escape that. Then I'll come again now from here now all the way down here. I have a beam here. Now, when you're following your beams, try to follow your white steel foundation beams where the major walls are going to rest on, where the major walls of the buildings are going to rest on, which is the major walls of the ground floor walls are going to rest on. Target your beam placement for your white strip along that line. So in this case, I'll focus majorly at the particular line where the major walls, block walls on the ground floor are going to pass through. Okay, that is fine. All other non-major walls, for example, toilet walls, can sit directly on the DPC slab after we have done our what damp proof course. Okay, and that. So in this case now, I'll then continue and then click here. So knowing that principle, that should guide you on how you are meant to do what insert your white strip foundation beam or ground beams. Okay, that is fine. So once we're done with this now, we'll then go ahead and then design for the footing. Note that I said that white strip foundation consists of a footing and a beam. So currently now we are first doing inserting the beams. This is not yet the design. We are only currently doing what? Insertion. After we have done this, we'll now move on to designing for the um, for the footing first. Then once we're done with the footing, we'll then move on to now design the for the beams, for the ground beams, which I'll show you how to design for your ground beams. Okay, and also how to arrange your reinforcement, because most times if you don't arrange your reinforcement well at site during the construction, you'll be having issues. Okay, that is fine. So I'll escape now and then continue again from here to here. Now note, if you want to purchase 2026, Protastructure is still available. So I'll then continue again from escape from here to here and then escape that. Okay, sorry for that. Come back here again, properties of that, then continue again from here to here. Okay, that is fine. I'll then continue again from here to here to here. That is fine. Okay, and then I'll then move for, let me escape from here to here. That is fine. Okay, so make sure you make sure you pass you connect your columns with a ground beam, and also focus on where the major block walls are going to rest. Okay, are going to pass through. Okay, but the whole essence is that you connect all the columns together. Okay, that is fine. Now, there are most times you can combine a foundation. You can combine foundations. When I mean by combining a foundation, what I mean is that you can combine ground beam, you can combine white steel foundation and a pad footing. For example, if there is a column that is not carrying much load, or much load is not on that column, you can then use a pad foundation for that. For example, you can see this particular one here now that is just on its own. This column is basically a fancy column, not carrying much load. I can choose to use a pad footing for this. Why the major ones I use a white strip. Okay, you can choose to make that type of what decision. Okay, that is fine. So I'll come again, continue again. So I can choose to use a pad footing here and then later connect it with a ground beam, but not up to 750 depth, maybe 300 or 450 minimum. Maximum. Okay, that is fine. So I'll come here again, continue again like this again, and again escape. Now when you are connecting your beams, you can see when you are making your, basically when you're doing your GA for a building that will carry a wide strip foundation, try to perform your GA or your column position in a way that all the ground beams are going to have columns end to end. What I mean by end to end, you can see that this column, this beam here or this wall along this line has a column here and has a column here. Because if you don't have column end to end, it will be difficult for you to actually perform that wide strip footing design for that particular beam. Okay, that is fine. So I'll click on this now. This is also a fancy column too. Again, I'll then come again now, click here, and again move all the way down here. Click here, and again click from here all the way down here. That is fine. Okay, that is fine. So again, I will then escape again, escape, click from here all the way down here. That is fine. So now once we are done with justifying that, okay, I see you have more one from here all the way down here. Okay, that is fine. So make sure you have inserted all the beams as you're meant to insert it. Let me check now again. Let me confirm again. So make sure you confirm again. Confirm. Now once you're done verifying all the columns, or sorry, all the beams for your ground beam, so once you're done verifying all your columns and sorry your beams, you can then move on to the actual footing design for this wide strip foundation. So we have just done the first step. Let's now move to the second step. It takes actually four steps to perform a wide strip foundation. The first is to model the ground beam, which we have just done just now. You can see the ground beam now have been modeled everything. Now let me just go and turn off the grid line because I am done using the grid lines. So I'll come now and then turn it off. Okay, that is fine. So once I do that now, just to have a clearer view, now this is the first step, is to model the ground beams or the wide strip beams. Now once you have done that now, the next thing to do is now design for the footing. But first, let's go and save. Then we'll now have what design for the footing, and once you're done for the footing, we then move on to the ground beam design, which is the wide strip beam design. Then after that, we then move to the what detailing. So that is the four steps for checking, then detailing. Okay, that's fine. So with that now, let's now go here. Now on this now, let's now begin to design for the footing. Now on this stage 2, which is the footing design, how do you now design for your ground beam, or sorry, for your wide strip footing? You do it by what? Clicking, holding your control key and selecting the beam on that entire grid line. So you can see that this is a line. I'll hold my control key and select all the columns, all the beams along this line. If I want to design for this other that line, I'll hold my control key and choose all the beams along this line. Okay, so this is the procedure to do that. So let's just start with this particular one now. So I'll come here, hold my control key, click on this, and select all the beams along the line. And I'll just right click now and then click on what? Insert strip footing. I will click on this insert strip footing here and then wait for it to display the dialog box. Now, this is the dialog box for a strip footing foundation. You can see it here, strip footing, project, pro doctor. This is the client's name on that. Now, once you come here, the first thing to do is to check this design environment. Remember, this is the first thing to do because it is very easy for you to forget this. And once you forget this, all what you have done is not to standard, is not useful. So make sure you check this design envelope before you can continue. So once you have done this now, the next to do right now, you come here and make sure you choose what? Your fan footing bar size. Now, you might end up seeing diameter 13. That is if you didn't choose or use the settings that we did the first time when we go and verify that the material for the reinforcement for the foundation is 12, and make sure it is there. If you don't do that, you'll be seeing 13 diameter here, and that is what it will use to do what for your footing design, which is not nice. So make sure you choose what 12 for your footing. Okay, so you now come and choose 12. Now once you have choose here and then choose here, then come here, this footing place here, make it 0. After our design, we are going to see the actual designed footing width. Make it 0. Come to this place, footing depth, make it 250. Come here and then make it 500. The maximum you can have here is 1000. Okay, same thing here too. I'll say 500 instead of 1000. That is fine. Now once you've done this one here and choose this, put this depth, make here to be 0, and then change here and change here, then come here and then click on what, design. Okay, don't bother picking anything here, leave it as it is. Now on that design, now note that I am using Eurocode, so any code you are using, follow the same principle. Okay, that is fine. Now once you have come here now, all right, you can choose to generate the report or leave it later. You can still get your report later. Then come here and click on what, OK here. Now you can see now we now have what, our footing width, but watch, it has an improper dimension. This is not an engineering dimension, in the sense that if at site I ask to measure this with your tape, it will be difficult for you to measure it, right? And just to avoid confusion to the laborers at site or to anyone at site, try to have a round figure for your footing width. So if in case you have a value like this, round it up to a normal value. All right. For example, now I have 1097.01. I can round it up to 1.1, which is 1100 millimeter. So I'll come now and say round up to 1100, which is very easy for them to measure at site. Now when you're rounding up, don't round up below, always go up. For example, we have 1097.1. Don't go and say 1090, because you are going below the design. So make sure you go above. If that's okay, that is fine. But if you don't understand, drop on the comment section. I will explain more later. Then come here now and then do what, say okay. Now they are asking which method do I want to use. I want to use this analytical method, although you can choose any one, but choose the one you are using. Okay, so I'll come here and I will choose this analytical method. I'll come here and do what, say okay, although you can see that you can change it later. I'll come here and then do this. They will only ask you this for the very first time. You can see they say this method will be used for all other design strip footing. Yes, they will ask you for only the first time. So I'll come and do what, say yes. Next one we do, they will not ask us again. So you see our footing will just appear just now here. Now you can see our footing here. Let's now go to the 3D view to see how this appears. If I come here now, you can see how this footing appears here. Okay, that is fine. You can see it here. It shows like a T having a beam and then a footing. So this is the footing and this is the beam. So currently now we have just designed for the footing of this particular beam. So do it for all these beams you are seeing here. Okay, that is fine. Let's now do for this other one. So you do it for all the beams you're seeing here as they are. Let's do for this other one now. Click on this, hold my control key, this, and then right click here and then say what, insert what, footing, strip footing. Okay, that is fine. Insert strip footing. So I'll come again now. Make sure you check this. Make sure that this is what, 12 diameter, and then come here, 250. Come here, make it what, 0. Sorry, 0. Yeah, 0. Come here, 500. Again here, 500, and then come here, say what, design, and then come here, okay it, and then you can see here it's showing 280 point. This is not a proper engineering dimension, so I'll make a round figure of what, 300, which is the nearest, or 2285. But let me just say 300 is more easier to measure at site. So I'll come here, 300, and I'll come and then do what, say okay here. That is fine. So once I've done this now, the next thing I'll do now is to do the next one again. So make sure you do for all the beams. Now if you have any questions so far, you can ask on the comment section, or you join our global WhatsApp group, which you can interact with other engineers too. That is fine. Then note that we are currently running 50% discount on our Ekidel mentorship training. So if you want to be a part, you can use the link below or go to Google and type Ekidel mentorship program, and then you will see the link over there and follow it and then enroll for that. Don't miss this opportunity for those that have been saying that our training is expensive. And then you can also see the course outline, which what you're going to learn by the end of the training. And then you also have a competency certificate for your training. Okay, that is fine. So I'll come now and then click on this place here, and then come here and then click OK. And here I'll make it a round figure. Here it's doing 1060. I'll say 1100, and I'll come and do what, say OK here. That is fine. So same thing for all. Let's go and do the one that is at the middle and see how it will behave. Again, here, and then click here, and then right click now, and then say insert type footing. That is fine. And then I'll come again now, and then check here, come here, make sure here is 0 here, so make sure here is 20 and 12, and then 0 here, 250, 250, here is 500, all right, 500 here, again here too, and then come and do what, design. Then say okay, look at this place, make sure it is what, a round figure. Okay, so I'll come here and do 300 again, and I'll come and do what, say okay here. Okay, that is fine. And I will come to this other one now here, click on this one, then click here, and then click here. Now when it is getting bigger, there's a point where the strip footing getting bigger, you will have to do what, move to a BINRA foundation. And when that point reach, I will let you know, because there's some size you will see for your strip footing. You will have to do what, change the foundation type to a higher level of foundation, which is what, a beam raft. Okay, that is fine. So you have 250 here, that is fine. Now the next video I'll be working on, or we will be doing here on Ekidel, will be on a mat foundation design. Yes, we have not really done that before, but that is part of our Ekidel mentorship training syllabus. But we will just do that for, let us go now and do what, here is 0, that is fine. Then 500 here, and then here too, and then design, yeah, that's fine. Design, say okay, and then you can see here it's doing 1388. I can come here and do what, 1385, which is a normal figure for measurement, or I come and say 1400. I say one figure at once, and I'll come and do what, say okay. So make sure you don't go below that value, always go above the value. Okay, that is fine. Okay, that is fine. So let's now do for this other one now. Now you can see that they are too close. Let's see if they will clash. If they clash, I'll tell you what you will do next. But let's see first if they will clash. Now I'll come now and then click on what? Insert. Insert. Make sure I do that way. Let me see. Come back again. Click here. Click here. Click here. And then click here. Right click now. And meant to show insert footing. It didn't show here. So if we are clicking, like, okay, yeah, you can see it here, insert strip footing. So I'll click it. Now if there is a clash, I'll tell you what to do. Let's just hold on again, and then come again, click here, make sure here is 12, then come here 250, 250, and then come here 0, and then come here 500, and again here 500, and I'll come and do what, click on here and then say design, and then let's see, say okay here. Then you can see the value here, 1472. So the nearest whole number now is meant to be 1475, but let me just take 1500, which is a good one, and I'll come and do what, say okay here. Now don't put that value too far, and don't never you go below. So you can see that it is not clashing. Okay, that is fine. Now had it been it was clashing, then you would have choose either to look at this line of wall. If it's a major wall that you cannot ignore, then you can then change the choice of foundation, because if there is a clash, you can either choose to ignore that wall line and then use only one wall line, or you change the choice of foundation. Okay, that is fine. Then I'll come again now, click on this to put the next one. Click on this. Right click here, come here, click on this, and then once that is placed, so you can see that it's just by you repeating, but make sure you are not missing anything. All right, you know that I'm meant to pause this because you can see that I'm just repeating everything, but this one I'm keeping it for you to see the end of the whole process. Okay, that is fine. I'll come again now and then do what, come here and do what, click on design here, and then click on OK, and then here will be 1200, 1200 here, and I'll come and do what, OK here. That is fine. Okay, that is fine. Then come again here, click here, right click here, properties here, here, insert here, and then click on this design envelope. Yes, then come here 0, come here 250, 250, come here 500, come here 500, and then design, then say okay, and then come, this is 1500, 1500 approximately, say okay, that's fine. And again, let's come here, click on this, and then this, right click here, properties. Okay, no, here insert zip footing, and then come again, come again, what the display right now. Click on design envelope, and then click on check whether it's 12, and then make it to be 0 for footing 0. Come here 250, and then come here 500. I can just say a and copy, come here, paste, that is fine. Then design, and then come here okay, and here is 26, so I'll come here and put 2700. Okay, that is fine, and then say okay. Now when it's getting bigger, for example, you're having like 5 meters as the footing width, that's a very too big. What it means is that white strip foundation is no longer advisable to be used. Okay, right? So you can choose to move to it is good you move to it is good you move to other type of foundation, which is a beam wrap foundation. Okay, that is fine. So I'll come now, click on here, insert part footing, sorry, strip footing, check this, and then come here 0, 250. Okay, come here 500, come here 500, and then design. Okay, that is fine. Okay, it here, and then here can be 1050, 1050. Okay, that is fine. And I'll come and do what, say okay, it's okay, that is fine. And then I'll come again now, click on this here, right click here, insert strip footing. So you can see I'm taking my time to like do this. That's to show you the actual step by step how you're meant to perform a white strip foundation. Okay, this is actually a crash course for a white strip foundation. This should be 500. Okay, that is fine. 500 again. Here should be 0, here should be 250, and then design this, and then say okay, and then here you can see here, make sure you change this value, else you have issue at site. So come here, and then here I will use a whole number here, so I'll use 1650 or 1625. It's okay, 1625. That's fine. And then because that's higher than the value which I got, I'll come and do what, say okay here. So make sure your value is higher than the value that you get. Okay, that is fine. Now if you enjoyed this video, please subscribe to our channel, and also recommend your friends and colleagues to this particular video, or to what's happening on Ekidel to want to learn structural design Ekidel here. Then here to be 0, here is what, 250, 250, 250, and here is what, 500, 500, and then come here, design this, and then okay that. And you can see here I'll take a maximum 1750, which is the higher value, and I'll come and do what, say okay here, that's fine. Then that will enter, and now move to this other one. Now you can see how this, now there is a way they perform the structural detailing or the foundation layout for how they represent it, okay, which you can get in Stonebridge template. You can see how these things are stopping on the way. They're not meant to stop like this. They're meant to be arranged later, which you can get samples on our Ekidel Stonebridge template. So I'll come now here 500. So you can get that too on our Ekidel online store, which you can find on our bio or below this video description. here will be 0, here will be 250, because basically it's not actually about design. If after designing you cannot then represent your design in drawing, then you have not done anything, because what they are going to use at site is not your design report, it is your detailing, which is on your white paper. Okay, that is fine. Here will be 1250, 1250. Okay, that is fine. And I'll come and do what, say okay. So I believe in you. You know why I'm changing that value is because the value which I'm getting are not measurable at site. Okay, they are not engineering measurement value. So you have to make it to be as simple as it is for them to understand at site. Okay, that's fine. So I'll come again now and then click on this. Come here, 500, 500, here 0, here 250, here envelope design, and then design. Say okay. Here I will change to 1650. That's nearest in whole number. 1650. That is fine. And I'll come and do what, say okay here. That is fine. Again, I'll come now. Click on this. Let me see this one here. This other one now. Here. Click this. Click this. Zoom here. Click this. Right click here. Then come now. Click on this. Insert part base. So insert strip footing. Okay, strip footing. Then come here. Check this. Here must be 12. Come here 500. 500. Come here 0. Come here 250. Alright, that is fine. Then design. Okay, that is fine. And then say okay. Here you can see a 20208 something. So I'll come and make it what 2100. Make sure you don't put a lower value there, else it will not show a warning, but you have caused a blunder. So make sure you don't put a lower value of that value that was shown to you. That is the minimum design width. So you have to put a higher value, a bit, not too far, not too high, just the nearest whole number. Then come and say okay, that is fine. Then I'll come and now and then click here, right click here. So you can see I'm taking then grid by grid. Okay, that's fine. Then come here, click here, and then click here 500. Oh god, 500 here, 502. Then here 0, here 250, 250, and then come here and then come here and then click on what, design. That is fine, design. Okay, that is okay. And then come here, click here, and then here nearest number there is 2100 again. Say okay, that is fine. We then move to this other one now. This one here. I will click here, click here, click here, and then click here. Right click now and then insert strip footing. Okay, that is fine. And then move on to click on this. Now if you have any error on your own while trying this, make sure you can comment below the comment section, or you use the Ekidel global WhatsApp group, which can get a link anywhere on a video, or chat us up directly and I'll send you the link for you to interact with other engineers, and they will help you on how to, if you have any issue, okay, while you're performing your design. That's fine. Then come and do what design here, and then come here, say okay. Here is 2213, so I'll come here and say 2225. That's nearest whole number, and I'll come and do what, say okay here. That's fine. Okay, that is fine. And I'll come again now. Let's see the one now. Click here and then click here. Right click here, proper insert strip footing. Okay, that is fine. Then here 500, here 500. Check this, and then here 0, here 250. That is fine. Make sure you check this because it's very easy to forget this. Okay, that's fine. Then click on this. Okay, that is fine. If you have any doubts that you have checked or not, go and delete that footing and begin that one afresh. Just to avoid that. Okay, that's fine. Here will be 1475 nearest number. That's fine. And then say okay, that's fine. And again, come here. So just to avoid doubt or guessing, just go and delete that footing that they're having doubts, and then you can then go back and then do the writing. Okay, so can come here right now, say 0, here 250, here, sorry, you can see 250, and then here 500, here 500, here must be 12. Then come here, okay that. Then design, okay, then come here, change here will be 1575. That's the nearest whole number, and then come and say okay here. That's fine. And again here, this is that one now. Click on this. Okay, click on this, hold my control key, click on this, right click now, insert here, and then come here, 500, come here 500, come here 0, come here 450. Okay, that is fine. Here designed, and then sorry here, sorry 250 here, 250, then design here, that is fine. And then this is a real life project actually. Then come here, yes, you already 1000, that's okay. Then come here and do what, say okay, that's fine. Then you can see that one gave us directly 1000, which is the actual, which is the engineering measurement. Okay, I'll leave it. That's why we didn't add anything there. So when you have an engineering measurement value that will not give stress at site, you can leave it as it is. Else you have to do what? Edit that. Here 500. Again here, designed. Make sure here is 12. Come here 0. Come here 250. That's fine. Then design. Okay, it's here. You can see here 2030. I'll come here and put 2050. Okay, that's a good value. Then say okay, that's fine. Now come here now. You can see that we are almost done. Okay, come here, right click here, insert this, then check this. Here must be 12, here 500, 500, here 0, here 250, and then design here, and then okay here, and here make sure here now you can see that almost 2850. So I'll come and do a 29 or 2875. Okay, that is fine. And I'll come out and do what, say okay, that is fine. So with this now, we then move to now. I'll show you how to correct all this when you are doing detailing. Okay, how to make them to be right. Okay, that is fine. Then we then move to the last one, which is here. Okay, which is here. Click on this. Click on this. Right click here. Come here. Insert part base. I pray it doesn't clash actually, but I pray it doesn't clash. Then come here, 500. Come here, 500. Come here, 0. Come here, 250, and then check this. Make sure here is 12, and then design. Okay, it's 1010140. This I will take 1425 is okay. And I'll come now and then do what else. I would have done 1405. I can take 1410. Yeah, it's a good value for measurement. And I'll come and do what, say okay here. Let's see now how it goes if to clash. No clashing, that is fine. So you can see that we are now done with the design. We have designed all the beams using the footing. On my 3D view now, you can now see how they appear. Now this will be a individual footing. You can see now how they appear. During our detailing, I will show you how to treat all these edges. Okay, how to treat them. Also this one too, how to treat all these edges, because they won't be like this. Okay, that is fine. So again, I will then move to you can see everything's fine there. So I then move to back to this place now. Now this that one here, I'll be using part footing for this. Later I'll now connect it with what, a ground beam. So I'll come now, right click here, which is a combined footing, and then right click here, because now this one using combined footing is because it's not carrying any much load there. If you go to 3D view now, you can see that column there is only, it's not really carrying much load, only the roof beam load. You can see that it's not really carrying much, so I would have to do it that way. So I'll come now, right click here, and then I'll say insert combined footing. Okay, that is fine. Now knowing that the bearing capacity is 65, you see that our footing base will be a bit big, but let's see, we are going to strengthen the column base up using a ground beam, like using a ground beam to connect the column, like to chain it. Okay, that is fine. So you can see you're having 2.3.3. Okay, that's fine. I'll come now. The same thing, 250 is still okay. Come again here, check our pointing, everything is okay for pointing and share. Then go to our final check first. First of all, go to our uh, rebars here. Under rebar, you can see the spacing here for enforcement 12 quantity diameter 16. Okay, that is fine. 16. I can choose to come here and then say try 12 and see what I'll get. If it's okay, 12 is okay. Come again here, 12 is okay too. That is fine. Then here is okay for 200. Then we are adding what 12 top bar, because now you can see I'll add top bar. Why? Because I'm designing for a combined footing. Whenever you have a combined footing, combining two columns together, you must add a top bar to do what? To cover up for the counter moment that will occur at the top. Okay, that is fine. So I'll then come now and then do what? Say okay. So with this now, we then have this. Okay, that is fine. Now I can then come here, click on my display, come here, show my grid line to add my ground beam, but the ground beam here will be 450 and not 750, because this ground beam is not a wide strip ground beam. It is just, sorry, not this. I would have to go and take beam from here. It is just for there to help chain this, to give strength, more strength to the column. Yes, this part base is already okay, but to just give more strength to the column, I'll use a beam of what? 300. No, 450. I'll 450. 450, and then I can choose to use the width to be 225. Okay, because I've already given a base for that 225. So I'll come now and then click on this and then click on this here. That is fine. And again, from here to here, that is fine. So with this now, let's now escape and then come back to our 3D view here. Can I see what we have just got just now? This is what we got. Let me turn off again my grid lines because it's to have a clearer view. That is fine. So you can now see what we just achieved now. Now this is actually a crash course on wide strip foundation. You can see how we combined path footing to this. Okay, this is really actually a real life project. So you can now see how we have achieved this now. Then let's now move. Now we have done the stage 1 and the stage 2 for this wide strip foundation, which is the beam modeling and the designed footing. Let's now go and design for this, because this beam is not yet designed for. How do you know that now? Let us now go to plan view. But okay, we can see on this view. Go to design here and then click on what? Foundation beams. You see that these beams are not designed for. You can see that they are all failing, because what we designed for was first the superstructure, which you can see here. Okay, which you can see here. You can see that the beams are still not showing designed for. Okay, that is fine. And you can see that this one now, this part footing is showing green. Now you'll be asking yourself, I said that we have designed for the footing for the beam. Now the reason why this footing will not show green yet is because this beam has not been designed. You can see that they are together because they are a whole structure, they are a whole foundation. So since they're together, since the beam is not yet designed for, then the part footing will not be designed for. The footing for the beam, which is the wide steel footing, so you have to design for the beam before this now also show green. Okay, that is fine because they're together. So you have to go back now to now design for the pad for the ground beams, which is the wide steel beams. Okay, that's fine. So back now to our foundation beams now, which is under design here. Come to design here, come to foundation beams here. Now once you have come here, you can see that all your beams are failing for the foundation. You can see the story active story is 0. So these beams are now, why are they failing? Because we have not yet done the design. And how do you do the design? You must, if you just go and click on what design here, they will fail. They will fail because now for the ground beam not to fail, we need to perform some settings, and those settings are for the design of the wide strip foundation beams. Okay, that is fine. So we'll come to settings center here, and on this place we then come to this place that says under beams here, click on beams, then click on parameters. Now once you're here, now you can see that we'll have floor beam, rib beam, and foundation beam. Now click on what? Foundation beams. Then on this place now we have minimum beam steel, which is you can use 12. But for beams, use 16, not 12. Then maximum beam steel, come here and choose what? 25. Okay, that is fine. Then here you can leave this as 16. They can see here they says lengths, diameter, minimum and maximum. Come here and choose 10. Then maximum choose 12. Even if it will use 10 and not 12 at the end. So make sure you choose at least minimum and maximum. And then once you've done that now, we then come here. Very very important here. This one is very important. This is what concrete cover. Then come here now and then pick here, right? Type here 35, 50, 35. So this is the concrete cover. Most times you can use 50 and 50 and 50. That's because it is good. This is a foundation what concrete cover. It will have direct contact with what, with the soil. All right, you can use here to 40, 40, but this must be 50 because this is the what beam bottom edge. It must be 50, but most times people just use what 50, 50, 50. Had it been you're using what American code, you would have used what 75, 75, 75. That's fine. So but now we are using what, we are using Euro code. Okay, so you can use 50, 50, 50. If you're using BS code too, 50, 50, 50. Okay, that is fine. So with this now, once you've set this, okay, and then you come here and do what, say okay. Now on saying okay now, click on what, save here. Okay, that is fine. If you now come back to your design, start and design now, and then click on foundation beams now, and on this now, on the foundation beam dialog box now, then click on this place that says what, beam design batch mode. Now on this place, make sure you come here and select this that says reselect all steel bars. You can choose this or you choose this. So I'll come here and say reselect all steel bars, and then click on what, come here and click on what, calculate here. Okay, allow it to finish up the design procedure for the beams, for the ground beams, which is for the wide steel beams. Okay, that is fine. So it will soon be done with this. We then go and check the foundation beams if they are designed or not designed. Okay, that is fine. So let's now hold on for that to finish up. For now, it's almost done already. Now if you enjoyed the video to this extent, please like our like this video, and also subscribe to our channel if you're not subscribed. And if you're an old subscriber, you can join our Ekidel mentorship or membership here on YouTube. But I would advise you join our Ekidel mentorship training, which is a one-on-one training. Okay, so right now we're not done with this. Now let's now do what, click on what, close now. Now if we now close this, okay, close this button now, by here, like I said, everything here is in design, although some are still failing. Now even if they have been designed, we will still check them again to see the kind of what reinforcement that was used to design for this particular what beams. Okay, that is fine. So but let me just close first now, and then go to our 3D here, then go to our design status here under review, then check. Now you can now see that I'll go and turn off my grid points, my grid layers. Turn off. You can now see now that both the footings and the beams are now showing what, green. So even if you've designed for the footing, as long as the beam is not designed, it will not show green. So we can now see that they're not showing what, green, which means what, designed. Although most beams are failing, you can see that. So we can check why these beams are failing and why these beams are coloring green, why they are passing. You must have to question the software. Don't depend on what the software is giving you, but rather you are the engineer to do what you as engineer, you need to check the software. Okay, that is fine. So right now you now go back to the design here, and then foundation design, and then begin to check each of these particular beams. Okay, I'll just come and do what, say, then say okay. Yeah, now you have to do what, arrange the reinforcement and then correct all these things that are not showing well here. Okay, that is fine. Now I'll be doing that on our next video, because this video is already 1 hour, almost 1 hour plus. So let us just stop this for today and then move on to the check-in on our next video, which will be coming up on for this particular training. Okay, that is fine. So I'll title this video crash course on white strip foundation using the software Protastructure part 1. Okay, that is fine. So my next video will be on the final stage, which is the checking of the foundation beams, okay, which is the white strip foundation beam. But this is how to design a white strip foundation beam. Okay, that is fine. So thank you so much and God bless you. See you on our next video for this particular crash course again for our beam wrapped foundation. Bye now and God bless you. Bye then.